Hi folks, Greg Marchand here with the TechNet Academy. I wanted to say a few brief words about the current national promotion, the $25 cash back on the gold and platinum AGM CarQuest batteries. And not only do I want to say a few words about that, but I want to give you an idea of how to use this national promotion so that you can grow your total revenue and your gross profit and make that marketing program for your organization something that you can just plug into year after year after year, so you don't have to think too much about it, and it's really effective. So here's the current promotion from November 1st to January 31st. Your consumer can get $25 cash back on the purchase of CarQuest Gold and Platinum AGM batteries. All right, $25 prepaid Visa back to your customer if they fill out the online form. Now, few rules real quick. Limit one purchase per consumer vehicle. Offer valid from November 1st to January 31st, 2018. Offer for CarQuest Gold and Platinum Series batteries installed by you, the TechNet Professional Repair Shop, and they get the cash back in the form of a $25 prepaid Visa gift card. For a complete list of the rules, visit technetprofessional.com and find this promotion. Small change this time in terms of this promotion. You know how you usually get some marketing materials, some posters and whatnot from your advanced driver or your advanced rep, or maybe they're shipped directly to you depending on where you are. It is not going to be automatically sent this time. So you will not automatically get posters in the mail. Now, if you want the posters, you can still attain them. In the meantime, you can get images for your website and your social media from technetprofessional.com if you follow all the links I'll give you before the end of this quick presentation for the national battery promotion. You follow those links and you'll be able to download these things. If you want the posters, we can get those to you. You just have to order them through the material order section, and we'll show you how to do that in just a second as well. The instructions for all of this are located in this real eye-strained slide that you cannot see. But just trust me, I'll give you the links in just a second, okay? Now, what I want you to do with this, like I wanted you to do with the break special we talked about a while back, is I want you to create a get ready for winter, fall-winter special. All right, many of you do this anyway, so maybe you want to try this and change yours up and see how this works, or use this to coincide with this battery promotion. But create a get ready for winter, fall-winter special. And what I like to include in that is a battery test. Well, that's probably already part of your courtesy inspection, right? If it's not, should be, think about it. A tire inspection, rotation, and alignment. Whoa. More on that in a second. An oil change? Obviously. Wiper blades. Huh, okay. And a courtesy inspection. Now, what does this do? Customers have a awareness of certain things, right? Now, we also have two things in this special that have printouts. Customers have an awareness that before winter, they should probably have the battery looked at. And the battery test equipment these days comes with a test printout. So we can print out a piece of paper from that little computer to show the customer the status of their battery. And the customer looks at that piece of paper and they go, oh wow, the computer says I need a new battery. I must need a new battery. You and I know it's not that simple, but guess what? It's third-party affirmation that I talk about in all these programs, right? That thing that printed out a piece of paper that's not a human, not trying to sell me anything, says that, and it knows more about my battery than I do, says that I need a new battery. Boom. Look, the alignment does the same thing. You can show them an alignment printout. No, most consumers have no idea what those numbers, letters, and colors on that alignment printout are. But that's not the point. They know green is good, red is bad, and we can sell an alignment. So when we do the alignment as part of the special, of course, we can show them the piece of paper, the before and the after. We also have the opportunity to get the wheels off the car and take a look at all the undercar components that are associated with the alignment. So we can possibly grow incremental revenue and gross profit there. Oil changes, of course. That's another easily recognized item that customers know they need. So they know they need a battery. They know cold weather is coming in many parts of the country, so they have an awareness. So the special will connect on that level. They know they need an alignment because alignment protects tires and makes their car go straight down the road. And for us, it can sell undercar components. So they're connected to the alignment as part of this special. So there's two things they have an awareness of. They know they're going to need an oil change. So look, even if it's December or January right now and they're due for an oil change, hey, you know what? I might as well have my battery tested, and I probably need an alignment as rough as these roads are around here. And then when do they think about wiper blades? Only when they absolutely have to have wiper blades, right? When they turn them on and, oh my goodness, I can't see anything. It amazes me the condition of some of the wiper blades out there, right? So we've got 4 touch points here that customers have a very high awareness of. Now, if you can offer this for the right price or as part of the right special, you will drive your customers to your store and you will make more money. All of these bring peace of mind to the customer, and you can save them an additional $25 should they need to purchase a battery during these 3 months of November, December, and January. It gets the wheels off the car, which helps you do a proper inspection and upsell, and then it builds that incremental revenue from those upsells. All right, so think about doing this. Now, you can also get creative with some of your marketing around this special. You can run a social media campaign. Maybe you use a countdown special. So, for instance, on Monday, you do this entire special for $49.95. What? Seriously? $49.95, Greg? Yep, $49.95. Because on Monday, we just want to get people's attention. Now, can they run right down and take advantage of it? Maybe not. But on Tuesday, it goes up incrementally to the point where by Friday, you're going to run this thing for, $199.95. So the hope is we want to get customers in Tuesday, Wednesday, Thursday, and be able to get the wheels off the car, do the inspection, etc., and get them in at the point where the gross profit is there. It's not a price that they go, oh, I can't afford this. They're still excited about the prices, but you start to build some more gross profit. Maybe on Monday you don't make much gross profit, but maybe you sell a battery, maybe you sell tie rods, ball joints, whatever it may be once you get your eyes on the car. All right, so use the countdown special idea to create some urgency. You could also just promote a free battery inspection. Look, you have a slow day this week, put that out there on Twitter. Free battery inspection today only, and just see if you can get some bites. You should always make that battery inspection part of every courtesy inspection though. But hey, look, you know what? You get a really cold day or maybe the first really cold day of the season, throw out free battery inspection. Somebody that morning had some issues or they started to think they might have some issues. All right, so get creative with this. Pay attention to the weather. Use the weather to connect the customer with some of these components on their automobile. Don't just wait for it to happen. Don't wait for them to come in and say, hey, I need this. Go out there and tap them on the shoulder and say, hey, did your car start okay this morning? Yeah, it did this morning, but I don't know about tomorrow morning. Okay? You can promote just an alignment special or just a tire special, but use your social media to take advantage of some of these national promotions. Drive the customers in, take advantage of the weather this time of year, drive the customers in, save them $25, and look, you know what? You sell them a battery, here's what I want you to do. I want you to fill out that online rebate form. You fill it out, you take a picture of the invoice and the paper pad fill out sheet of paper you got to fill out, the rebate form I'm trying to say, and you upload those and you submit that for the customer. Think about that level of customer service. Nobody else is doing that, all right? But use these things to your advantage. Now, you're going to want more information on this. I know you will, so go to technetprofessional.com, click on Marketing Tools, click on Member Promotions from that, and once the Member Promotions calendar comes up, click on the November battery promotion. It will link you to the battery promotion page. Once you get to the battery promotion page, then you can link to the instructions to order the point of purchase materials, the posters if you want. You can download the images for your social media campaigns, and you can order the rebate forms, okay, if you don't want to use the online form. All right, folks, think about running a fall-winter special. Take advantage of this national promotion. Let your customers know you can save them some money. They're going to need some batteries. So get out there, keep up the great work, and never stop promoting. Hi folks, Greg Marchand here. Welcome to another episode of the Virtual Instructor-Led Training Program brought to you by the Service Sales Academy. In this episode, we're going to give you a little bit of technical knowledge for service advisors regarding engine control basics. And this is an effort to boost your technical knowledge at a very high level in terms of not a whole lot of detail, but language that you can use to help the customer understand, say when you're selling check engine light diagnosis. So review this on a regular basis and take from it what you can use, leave the rest. We're not going to go too deep down the rabbit hole. Okay, if you're a former technician and or you're a very technical individual, you're going to look at this and go, yeah, okay, Greg, that's kind of the way it works, but there's way more to it than that, and you would be correct. We're approaching this from the 30,000 foot level and literally keeping it as basic as we can in a very short time period too. So let's talk about what the engine control system does. Now, the general purpose of the engine control system is to allow the engine to run. Does it do more than that? Yes, it does. But basically, the engine control system ensures that the air-fuel mixture is correct and to keep the emissions as low as possible. So in other words, we combine air and fuel to make the engine run, but the wrong combination of air and fuel, not only will the engine run funny, but we can end up with excess emissions, which we don't want because we just have to breathe that stuff. The engine control system is also designed to alert the driver today of any problems that may happen. Yeah, 40 years ago it didn't do this, but today it's a major portion of what it does. It will also provide some data for diagnosis. And there are a dozen other things that it does that are less important than this. It sends a lot of data to a lot of other computers. It keeps an eye on a lot of things, including where you are sometimes. And let's just say right now that the engine control system is very, very complex. So the simpler we keep it, I think the better off we're going to be. Now, this diagram that you can see here just shows the very basic process that goes on with engine control. It's a computer. You'll see it called the ECM or the PCM. There's all kinds of acronyms for it. The bottom line is it's a computer, and computers really do three things. They receive input, and it doesn't matter whether it's your computer that you type on every day, that input is you typing. In an engine control computer, it is input from various sensors throughout the automobile. It receives this input, it does some math, it does some processing, and then it controls some sort of output. So the inputs that you can expect for the engine control system might be from the mass airflow sensor, from a crank position sensor, a camshaft position sensor, maybe the O2 sensor, various temperature sensors, and there's only a couple listed here. This is only a real brief list of the potential sensors. It takes input in terms of voltages or signals from these different sensors, and it does some sort of processing. And there are really three different ways that it processes it. It either does the math on its own, because it has the programming to do that, or it has pre-programmed data, and it says, hey, you know what? When these values come in that look like this number from these sensors, then here's what I do. And it grabs a number and it does something with it, and that would be the output. It can also learn. Very basic engine control computers 30 years ago, they weren't all that smart. They used a lot of lookup tables and did a little bit of math, but they didn't really learn much. Well, new computers, they have the ability to learn. They bring in the input, they process, they provide some sort of output, and then they check and see what that output was like, and whether it was close to what they wanted or not real close to what they wanted. And then it learns from that. And so next time it gets the inputs and it does its processing, it's going to modify the process a little bit in terms of output. So there's a lot that goes on, but the bottom line is it takes sensor data, it does some processing, and then it controls a solenoid, controls a motor, controls a switch, maybe turns a light on or off. I've got fuel injector duration up here only because that's a very major output in terms of that air-fuel mixture making the engine run and controlling emissions. However, that's really nothing more than a solenoid. So when I say fuel injector duration, that really sounds fancy, but it's opening up a valve for a set amount of time is all it is. So this engine control process is input, processing, and then output. Remember, the engine's got to have a few things to work. Really, it's got to have four things. It's got to have air. And you control air with your foot on the gas pedal. Why we call it a gas pedal, I don't know. It's always historically kind of been an air pedal. Now it's more of a gas pedal, I guess. But it's got to have air coming in. It's got to have some fuel to combine with that air. We got to light that up with a spark. And then we need compression, or the engine's just not going to run with compression. The engine control system and all those inputs, processing, and outputs we just talked about, it really just measures the air. it delivers the fuel by opening or closing a valve, and it times the spark, because if the spark doesn't happen at the right time, nothing good's going to happen. Air, fuel, spark, compression, and then the engine control will measure the air, it will deliver the fuel, and it will time the spark. It really, if you want to get really technical, it can control compression today, but let's just, for all intents and purposes, say it doesn't have a whole lot to do with compression. The very basic fuel injection system that's being controlled by the engine control system is comprised of these inputs, some sort of how much air is coming into the engine. That would be the MAF sensor or the MAP sensor, the MAF sensor or the mass airflow sensor, if you will, or the MAP sensor, manifold absolute pressure sensor. That determines the air that's coming in. It will have one or a combination of those, both, or a combination of them, I should say. It's got crank sensors and cam sensors because it's going to tell it where the pistons are and where the valves are in terms of the physical positioning of them, so we know when to deliver the fuel and whether they're open and closed or ready for us to, spark. Temperature sensors. We got to know what the temperature is of the incoming air, because that will determine how much fuel we should add or how much fuel we should take away. The colder the air, the more fuel we're going to want to give it. However, it's got more oxygen in it. So we use all of these sensors to gather the data so we can do some math. The other sensor, the last sensor here that we'll get back to in a little bit, the oxygen sensor, that's a very relevant input. It's a feedback sensor. It does look at what the result of all these outputs were, but it's a critical input for the next fuel injection cycle. Now, of course, if we're going to have fuel to be delivered through an injector, we've got to have some fuel components. And so here are the fuel components that are going to be controlled as part of the engine control system. You've got the fuel pump. Of course, the fuel tank holds all that fuel. You may have a pressure regulator in the tank, usually now, today, as part of the fuel pump sometimes still separate. Fuel lines and this electronic control module, it's actually going to run the fuel pump, and you may even look at fuel pressure. So I could have a fuel pressure sensor as part of this as well. There are many, many components that engine control system has to control. Remember, it's inputs, processing, and outputs. That's all it is. You don't need to know the nuances of all of that. Some of the ignition system components. Remember, we're going to deliver fuel. We're going to have a tank full of fuel. We're going to have a fuel pump we'll turn on to pump that fuel up to the fuel injector. And the injector is just an open or closed door. Well, once we open the door and let some fuel in, at some point we need to give it a spark to ignite this. And that's what the ignition system does. The ignition system components, real simply, are a coil, an ignition module, which is a separate ignition computer, and some spark plugs. Do you want to throw in the distributor cap? Do you want to throw in a rotor, some spark plug wire? Sure, we could talk about that too. But today's automobiles, they don't have any of that stuff anymore. They've got coils that sit right on top of a spark plug, and they've got a computer that turns that coil on and off to create the spark. And we won't get into how that happens, but just trust me, the computer turns the coil on and off, and the spark plugs happily spark away to ignite the fuel that we've delivered through the fuel injector, which is an open or closed door. Now, we do need some input in order to control the ignition system, just like we needed some inputs to control the fuel delivery portion of the engine control system. We've got to look at how fast the engine is spinning. We've got to look at where the camshafts are, because that tells us whether these valves are open and closed and whether we're ready to actually create a spark. A lot of that data is processed by the engine control module. Some of it may also be processed by the ignition module. And oftentimes they will work together to time exactly when that signal gets sent to the coil to turn that spark on and off, if you will, real simply. Now, engine control was one thing. That was mixing air and fuel together. And all those inputs just determine how much fuel are we going to deliver. We have very little control over how much air, other than what we do with the gas pedal and how far we push our foot down on a simple system. Today's systems, we actually operate the throttle with an electric motor, and your foot just tells it how far to go. We monitor the air. We determine how much fuel to deliver the system. But then, based on our decision, we're going to have too little or too much fuel, and all these other chemical situations happen, because this is all chemistry. It's all combustion chemistry. And based on what conditions were present and what our decision was in terms of how much fuel to deliver, assuming we're the computer, we have emissions. And we have certain chemicals that come out the tailpipe that we just don't want because they contribute in a negative way to everything that goes on around us. So we have separate emission systems as well. One of those emission systems that's kind of going away now, but still exists on some automobiles, is the EGR system, the exhaust gas recirculation system. Now, a lot of service advisors, I've heard some funny things from service advisors. Many service advisors make some stuff up about what the EGR is and does. And I heard one person one day say, well, yeah, you know what it is. It actually recirculates the exhaust gas and takes any of the unburnt fuel in that gas and puts it back in the engine. Well, sure, that sounds really good, but you know what the reality is? That is not actually what happens. Even though if we just read exhaust gas recirculation, we might think that might be what would happen. The purpose of the EGR is to actually reduce the combustion temperature so that we don't form certain gases and then stick them out the exhaust pipe. Okay, so the EGR it's a temperature control system. Basically, it sticks gases that cannot possibly burn into the combustion process and kills off some combustion. So we actually lower combustion temperatures. That's probably way more than what you need to know. Just know that it's an emission system that does control some of those exhaust emissions. And eventually you're going to see likely EGR go away on most automobiles because we can handle a lot of this with variable valve timing now. The other major emission system that you deal with every day is the evaporative emission system. The evaporative emission system is there to capture fuel vapor. That car sitting out there, and I really don't care whether it's 30 below zero or 130 in Phoenix in the summertime, that fuel is sitting there and evaporating. We can no longer vent it to the atmosphere like we used to. Now we have to capture it, hold it, and burn it again. When conditions are right, we'll burn it in the engine. So its job is to capture the fuel vapor, hold on to the fuel vapor, and then recycle it to be burnt in the engine. Now the engine control system has to know how much fuel vapor we have so that it can control the outputs to let a little bit of it in while we're giving it some fuel so that we don't screw up our air-fuel mixture. It also has to monitor all of these emission systems for proper operation. That is federal law. So the engine control system, in its real basic form, it figures out how much fuel to combine with the air that's coming in to make the engine go. In its more complex form, it not only monitors the air coming in, figures out how much fuel to deliver, but it looks at the decision based on what came out the tailpipe and modifies its next decision to try to reduce emissions. And then on top of all that, as if that wasn't enough, it has to actually monitor all of these components for proper operation. The last emission piece is the catalytic converter. And I say last emission piece. There are other devices that we will not talk about here. These are the three major systems today, and I believe I have them all right now. But the catalytic converter is probably the single most important emission device on the automobile. Its job really is to burn any unburnt fuel that is found in the exhaust. The science behind catalytic converters is extremely complex, and we won't get into that, but just know that it needs specific oxygen levels and specific fuel in the exhaust levels to work properly. And so the engine control system is always modifying its outputs to try to keep the cat happy. This device also is constantly monitored by the engine control system. It looks simple. It's actually quite complex. No, there are no moving parts, at least in this one. Yeah, there are a couple out there with some moving parts, but we won't go there. All right, it looks simple, but chemically it's very complex and does a very, very important job. Now, all of this kind of comes together in what we call the feedback loop. The engine control collects data on how it did. It does the input processing output thing. So it takes the sensor data, it does the processing we talked about, and then it controls motors, lights, solenoids, all this good stuff. And then it takes certain sensors in certain positions, such as the O2 sensor in the exhaust, temperature sensors maybe on the EGR system, or even in the engine itself, and position sensors sometimes, and it looks and sees, how did I do? Sometimes it just looks to make sure that the output actually performed what it was supposed to perform. So in other words, if a motor was told to go to a certain position, did it actually go there? And that would be the position sensor thing. So that's very simple. Okay, I told it to do it. Yep, it did it. Perfect. Other times it's, all right, so the air was coming in at this volume and it was this temperature, and I decided to give it this much fuel, and I want to see how much fuel is left over. And so it uses the oxygen sensor to determine, hey, did all the oxygen get burned up? Well, if it did, then it must have had way more than enough fuel. Did it not all get burned up? How much did I expect and how much did I really get there? And it takes this feedback, and that feedback becomes an input, and it modifies its output based on that next time. Probably, again, more than what you really wanted to know, but just remember, inputs, processing, output. When we talk about what could possibly go wrong with a check engine light, when that light comes on, what could it be? It could be anything to do with input, processing, or output. That's real simply what goes on. The system that determines where those problems may be is the OBD2 system, the Onboard Diagnostic System Generation 2. And I'll keep this as simple as possible. This is what controls the check engine light. And that check engine light, by federal law, has to turn on if anything might go wrong with the system that could possibly raise emissions levels to 1.5 times what that vehicle was certified at. So in other words, the federal government tests every automobile that leaves the plant to go out on the road. I say everyone, they sample them, and they say it has to meet these specifications. If anything with the engine control system could possibly go wrong that could result in those emissions rising, that check engine light has to come on. So therefore, the diagnostic system performs a series of tests, both on systems and on components, to determine how well they are functioning, and if they are functioning at the level at which they need to keep emissions low. The bottom line is, if the check engine light comes on, there's a problem that potentially affects the emissions. Here's the way I put it to a customer. If your check engine light is on, there's a very high likelihood that your fuel economy is about to suffer or is currently suffering. I connect fuel economy with a check engine light, and I go and say to them, we need to figure out what's going on here. It's going to cost you $150 to figure out what's going on. Once we understand what's going on, I can give you a repair estimate. And once they hear fuel with the check engine light, they usually go, oh, okay. Very different than saying, yeah, we can take a look at it for you. I let them know, hey, look, you know what, that light's on. There's a good likelihood your fuel economy is suffering. Let's get to the bottom of that. Let's figure out what's going on, and then I can give you an estimate as to what it's going to take to repair it. So for the diagnosis, it's $150. Most of the time, we can get the entire diagnosis done for that $150. If we run into any problems and it looks like this is something way more complex than I expect it to be, then you'll hear from me before we spend any more of your money. Okay? I gave you the check engine light diagnosis process that most technicians will go through. Just as an FYI, this is also available on the ServiceSalesAcademy.com website. It's simply, they gather the information, they pull all the diagnostic trouble codes and any data that's available to them. They'll record all of that stuff. They'll go out on a test drive. They'll try to duplicate the condition the vehicle was under when that check engine light came on. Yes, they can figure that out from the data. We teach them to do certain tests to figure out exactly what this problem is. That would be isolating the trouble. And then once they repair it, they have a repair confirmation routine that they go through. So it's not simple. It's not crazy complex, but it takes time. And if they do it right, it will take time. And usually within 30 to 60 minutes, they can get to the bottom of most any check engine light issue. Not all the time. You know, that might be good for 80% of the time. 20% of the time, yeah, it's going to be a little bit more complex. And that's just the way those things go. So now you know a little bit of information about the engine control system, maybe just enough that you can explain it better to a customer now. In summary, the engine control system provides the right amount of fuel to make the engine run and keep the emissions where they need to be. The engine control also constantly monitors itself in terms of systems and components to make sure that they're all properly operating. That onboard diagnostic system is the alert system, it just basically raises its hand and says, hey, you know what? I'm turning this light on. It means that we ran a test and that test failed. Well, why'd the test fail? That's what we got to figure out. It's not as simple as plugging in the magic computer and having it tell us what's wrong. It just tells us what test failed and what direction to go and look in. If that mill is on, chances are fuel economy is suffering, because remember what the engine control system does? It controls how much fuel gets mixed with the air that's coming in, and then all those systems surrounding that. Okay, folks, if you have any more questions, feel free to write me, email me. My phone number and my email are on servicesalesacademy.com. Until next time, keep up the great work and never stop learning.